Today we're going to be combining lesson 9 and 10, which is still continuing the idea of scale drawings. You're going to see a lot of similarities between what we've been leading up to with scale factor and scale drawings here today. And a couple of things to point out is with scale drawings, we are looking at a scale factor, and this is the definition here, that's shown as a ratio. And we'll look at a couple examples here in just a second. But instead of saying the scale factor is 2 or the scale factor is 1/8, and we're talking about a scaled copy getting larger or smaller, now we're going to be talking in ratios, most of the time with measurements, saying things like 1 centimeter is equivalent to 4 yards, or 1 inch is equivalent to 1 mile. So we're going to take a look at that right now. A couple of things. We want to simplify our ratio, our scale factor, so that the numerator is 1, that top number in the ratio. And that's going to create something that you've probably heard of before, which is a unit rate. A couple other things to remember is when we're making that ratio, we want the scale or the model measurement before the actual measurement. And in this case, we'll write them one over the other. So the numerator, the top number is going to be the scale, the bottom is going to be the actual. So if we look at the example here, with a scale of 2 inches equals 3 feet, I would write the scale measurement, the first measurement, over the actual measurement here. Now to get a scale factor, I want to simplify that. So I want a unit rate showing what 1 inch is equivalent to. Because I'm getting half the length in the scale drawing, I'm going to get half of the length in the actual item that we're talking about. So that would become 1 1/2 feet, or 1.5 feet. Same idea for the next one, where it says the scale is 2 inches to 4 yards. I wrote the model measurement, the scale measurement, over the actual, and now I want a unit rate. So what does 1 inch equal? And that would be half again, so 2 yards. Now we're talking about equivalent ratios. This is a proportion showing that these two things are equivalent to each other. They're not the same, but usually this is going to be preferred when we have a unit rate, a scale factor to work with. It's just easier when one of our quantities in the ratio is going to be 1. Let's look at these examples in the practice. I'm going to do 2 and 3 for you because I think they demonstrate some important things, and I would like you to try the rest on your own. So question 2 says scale drawing has a scale of 2 centimeters to 15 meters. If the length of something on the drawing is 12 centimeters, what is the actual length? So I'm going to, again, create a proportion. Now, yesterday in the video, I demonstrated with a table. And if that makes more sense to you, if you like working with a table, please continue to do that. There's no need for you to make a proportion because they do the same thing. So instead of creating that table today, I'm going to show you another way to do this, another strategy, where I'm going to take the scale given, put the measurement of the drawing over the actual distance to make that into a proportion. I'm going to compare it to the other quantity. Now in this case, I'm not finding the scale factor. I'm not finding what 1 centimeter equals. I want to know if a drawing has a length of 12 centimeters, which is still talking about the drawing, it still needs to be on the top of the ratio here. How many meters is that going to be? So here's where I look for the comparison. So we are getting 6 times greater in the drawing, and the actual measurement is going to have to do that same increase for it to be proportionate, just like all the sides on a scaled copy. Everything had to increase by that scale factor. The same thing between our ratios, otherwise they're not going to be equivalent. So I'm going to do 15 times 6 and get a measurement of 90 meters in real life to answer that question. The actual length of that object would be 90 meters when it's 12 centimeters in the drawing. Next question, two cities are 1,750 miles apart. On a map, the cities are 5 inches apart. What is the scale on the map? This one has us finding the scale. So you can, one easy way to tell is they only give us 2 numbers here in the problem. In the last problem, we were given the scale and something to calculate, something to find. Here we only have 2 numbers that are representing the same thing. We have 5 inches on a map and 1,750 miles between the cities. So that's the scale that we're given. I'm going to write the drawing or the map over the actual distance. And then when I set up my proportion, that other number that I need is going to be 1 because it said, what is the scale on the map? That's that unit rate that we talked about in the last demonstration, that unit rate that I want to find. Okay, so let's look at how that happened. 5 to 1. 5 times something equals 1. That sounds to me like the definition of reciprocals. When we multiply 2 numbers together, we get 1. So the reciprocal of 5 is 1/5. I need to balance, keep things equivalent by doing the same to the number of miles. And that's going to tell me that the scale for this map is now 1 inch is equivalent to 350 miles. I'm sorry. The answer would actually be the whole ratio, and that's how we're representing scales, is we're comparing these 2 quantities. Okay? Now, for the next activity, drawing a pool, it says if you have an actual rectangular swimming pool measuring 50 meters in length and 25 meters in width, what would be the scale drawing dimensions if the scale is 1 centimeter equals 5 meters? So we have the actual pool length and the actual pool width, and then we're given a scale. I like to draw a representation of this when there is no picture. I think it just helps organize your information better. I know this is the actual pool I'm drawing. So the width of the pool was 25 meters. The length of the pool was 50 meters. And now I'm going to be making a scaled drawing, so a much smaller version of that pool. And I can see because of the scale that the drawing is going to be measured in centimeters. So let's find out what the width of that drawing is. I'm going to start by setting up a proportion. Remember, that's showing 2 equivalent ratios here. My first ratio is going to be my scale, and I put the measurement of the drawing over the measurement of the actual room. Then I'm going to turn, let's do the width first. I'm going to turn that scale into what the actual width of the pool is, which is 25 meters. So to increase this actual measurement, I'm going to be multiplying by 5. 5 times 5 is 25, and I'm going to balance it here the same way. That means that on the drawing, it should be 5 centimeters for the width. One quick thing to notice before I do the length is these 2 things, the actual swimming pool and the drawing, should look similar. They're obviously very different sizes, but they should look similar. And I noticed that the width is half of the length of the actual pool, or the length is twice as big as the width. So I can assume if the width is 5 centimeters, then the length should be twice that, or 10 centimeters. But let's double check that by creating another proportion. I'm going to start with my scale, and then compare that to the actual length of the pool. Remember, that's going to go here on the bottom of the ratio. And keeping those lined up is very important. So keeping my scale drawing measurements on top, my actual, in this case, pool measurements on the bottom. And now how did those change? Well, 5 to 50 became 10 times greater. We're always using multiplication here. And I'm going to balance the top as well. So 10 centimeters, just like we predicted, would be the length of the drawing. Okay, lastly, let's take a quick look at the table. It tells us that one set of architectural drawings for a new school building, the scale is 1/4 inch equals 2 feet. Find the missing lengths of the room. And it wants us to first find the scale factor. Remember, the scale factor is going to be comparing to 1. So instead of knowing what 1/4 inch equals, we're going to find what 1 inch equals. If we're getting 4 times greater in our scale drawing, we need to get 4 times greater in the actual building. So instead of 2 feet, 1 inch is going to be equivalent to 8 feet, and that would be our scale factor. Now, we can set up a proportion here to find this first measurement for the lobby. So we're given the actual length of the lobby is 16 feet. We want to know what it is in the drawing in inches. So let's start with our scale factor. Now here, you could use either the scale factor or the scale we were given in the problem. They're both going to work. This one might avoid using fractions a little bit. So we'll do 1 inch. The drawing is equivalent to 8 feet. Set up our proportion, and now we have 16 feet. That's got to go on the bottom of my next ratio so that I'm lining up the actual measurements and finding the scale drawing measurements. All right, and then let's look at how those compare. 8 feet turned to 16 feet by doubling, by multiplying by 2. And we'll balance that here. So 2 inches is going to be the drawing length for that lobby. Now, if I go the other way and I'm giving the drawing length and need to find the actual length, I can do it the exact same way with just a few slight changes. So I'm going to set up my scale factor. Now, here's where I need to be careful. So I'm given 1.25 inches. That's on the drawing. So that's going to have to go on the top of my ratio to keep everything in line. Okay. How does this measurement change? Well, it's getting 1.25 times greater. 1 times 1.25 is 1.25. And I need to balance that here, which would turn 8 feet into 10 feet. All right. One quick thing to notice before we stop today is that this scale factor works in the same way as a scale factor that we were using with figures in some of the earlier lessons in Unit 1. So if you notice, as we go back and forth between these two columns, we're going to be using this scale factor to do so. I think that's really easy to see here in the principal's office. If I take the number of inches that we were given Every one of those inches is 8 feet. So I'm multiplying by that scale factor by 8 to get the actual length. And if I were to go this direction, I'm getting smaller. I'm going from 16 feet down to 2 inches. So I am multiplying by the reciprocal to go the other way, or 1/8. Okay, look for that pattern as you continue and see if it continues through the rest of these. But don't forget to practice setting up those proportions and showing those equivalent measurements. Please finish the table and the questions that we didn't do in the 9.2 practice, and then take a look at your practice problems. Don't forget, each practice problem has a video that helps explain it with those Mr. Morgan YouTube videos. And also remember that I'll be on Zoom throughout the day to answer any questions. Talk to you soon.